Okay, today we're going to use another method, and we're finding the volume of solids with known cross sections. So sometimes we can create a cross section, and then we can actually find the volume based upon that work. Well, here is a little integral that you should be using for cross sections of area taken perpendicular to the x-axis. So that's important, perpendicular to the x-axis. We would use the integral from a to b of the area of that shape, whatever that cross section is, dx. So I'm going to jump right into two problems that I'm going to do for you with these cross sections. My pictures do not do justice to cross section or the volume. You have to picture this in a 3D type situation where you have these cross sections of these equilateral triangles for this particular problem. Please look at the illustrations in the book on page 468 for a much better picture of what a cross section or what this volume would actually look like. So what I'm going to do is I'm going to set up about, because of the formula, I'm supposed to go from a to b of the area of the cross section dx. Well, the area of that cross section is a triangle, so we're going to just focus on this triangle. We know it's an equilateral triangle, meaning all sides are equal, which we know all the angles then are 60 degrees as well. What I know is that the base of this is determined by the circle, this x squared plus y squared equals 4. Well, I'm going to be able to figure out this base by solving for y. So I'm going to say this is y squared equals 4 minus x squared. And then I'm going to square root both sides, which gives me square root of 4 minus x squared. So that's what y is equal to. So this part right here is equal to that. So I'm going to draw down from the vertex of this triangle to represent this axis here. So this right here is equal to the square root of 4 minus x squared. That means this other side is also the square root of 4 minus x squared. So that means my base length, okay, because remember our goal is to find the area of this, is 1/2 base times height. So I know that the area of this triangle is now 1/2. The base is 2 of these, so it's 2 square root of 4 minus x squared times the height. I have to determine the height yet. The height is going to need to be determined using, you could do, basically the only thing we can do is use our geometry knowledge about 60 degrees. We know that this angle up here would have to be 30 degrees, so this would be the short leg. One of the tricks to that is taking that short leg times the square root of 3. I chose this one to do on the video because that is a process that most of you probably have forgotten. So if you take this short leg and multiply it by square root of 3, you will get the height. So it's square root of 3 times that leg. That is the height, and I cannot even squeeze that in here, but I'm going to write it underneath here at least. So now that I found the area of the triangle, I'm going to place it into the integral. So I now can find the integral. The integral is going to be -2 to 2 of this area, 1/2 base times the height, dx. Now this actually turns out pretty decently because 1/2 and 2 cancel. The square root of 4 minus x squared times the square root of 4 minus x squared is just 4 minus x squared dx, and the square root of 3 can come out front. So now when I integrate, I get 4x minus x cubed over 3. I still have the square root of 3 out front, and I'm going to plug in -2 to 2. I'm going to have to finish this up on the next video, but if you want to stop at this point and try to finish it, you would get 32 square root of 3 over 3. I will finish it later. Here's where I left off on that last problem. So what I need to do is just plug in my values. So I end up plugging in the 2, which gives me 8 minus, plug in the 2, 8/3. And then I have minus, remember square root of 3 is being multiplied by everything. So I'd have minus negative 8 minus negative 8/3. This gives me the square root of 3 times 16/3 plus 16/3, and that's just by me making common denominators. So when I add 16 plus 16, I get 32, multiplied by the square root of 3, all over 3. I think I said in the last video that you get 32 square root of 3 over 2. That was a little mistake. And this is the correct answer. This last problem I'm going to do of these, again, look at the picture on page 468. It's a much better idea of what's going on. We are going to need to find the area of that triangle. So I'm going to remove the triangle out. And what I know it is an isosceles right triangle. That means it has a 90-degree angle here with 45-degree angles down below. I'm going to find the area of that triangle by finding its base length. In order to find the base length again, I'm going to need to remember that when we solve this, we got y is equal to the square root of 4 minus x squared. So that means my base right here is square root of 4 minus x squared, and so is this side, so the whole length is 2 square root of 4 minus x squared. The height is going to be different in this problem. This is a 45, 90-degree triangle. So because these are both 45-degree angles in this small triangle, this one is square root of 4 minus x squared, so the height has to be the square root of 4 minus x squared also. Allow me to go ahead and write my interval now. So the volume is equal to, from negative 2 to 2, okay, because we're talking about on the x-axis, we'd write 1/2. I'm just going to put base times height dx first of all. So I'm going to say this is negative 2 to 2 of 1/2. The base is 2 times the square root of 4 minus x squared times the height, square root of 4 minus x squared dx. What happens is I have those canceling, and then I have the square root of 4 minus x squared times the square root of 4 minus x squared is 4 minus x squared dx. Integrate, I get 4x minus x cubed over 3 from negative 2 to 2. And then I'll just plug in my 2 and I get 8 minus 8/3. Minus, plug in negative 2, I get negative 8 minus negative 8/3. So once again, I end up with that 16/3 when I subtract these and make common denominators. And this becomes plus 16/3. This is also a negative 16/3, but it becomes positive because it's minus minus, which then gives me my final answer of 32/3. Please look at the book, I can't stress that enough, for the pictures of what those volumes with the cross sections look like.